Go for it.
Wonderful. Okay, everybody. So my name is Chris Swinner. I am the CEO and co-founder of Reach. Today, we're going to talk about breaking into blockchain with JavaScript. So there are three major problems with blockchain. The first thing is that it's too complex. When you're learning how to build blockchain development, you really have to learn how to develop low-level state machines, and it's just really extremely complex. Actually, and I'll go into that in a second. The second major issue is that it's costly for multiple different reasons: the expense of actually doing it, and also the safety reasons as well. And the final big issue is this culture. The crypto Twitter space is pretty much a cesspool, a toxic cesspool. So start off with the complexity issue. Like I mentioned earlier, is when you're building a blockchain application, you really are programming a state machine. It's a low-level functionality that you have to actually. You're not coding at the business logic. You have to know how to actually build how your application works and how things transition in and out. And just traditional developers just don't have a lot of experience building that, because that's not how web development is done. But it is something that you have to do in the blockchain space. Also, because it's so low level and you don't have that experience building like that, it takes a long time to get up and going. And I've been actually in blockchain for a very long time. And the thing that I always tell everybody is that if I'm asking somebody to build a blockchain application and it's like a DeFi application or what have you, if the developer doesn't have at least a year of experience full-time developing it, I don't think I could actually trust them because of the next issue. Actually, wait, never mind. So this will give you an example of the complexity of how things are. In the right here, you have a Solidity application, and the left, you have the Reach application. As you can see, there's a lot more scrolling going on. I think there's around 100 lines of code in Reach, and the same exact application that is output is around probably, I think, 1,000 lines of code. So there's a big difference between the two. To talk about really how Reach fixes this complexity issue, the number of lines of code are about 1/10 of what you would write. I'll give you a real world example. We're in the process right now of writing a AMM DEX, or like a decentralized exchange. And the exchange itself is around 250 lines of code. Compare that to if you wrote that in Solidity, it's around 3,000 lines of code. So it's about 1/10 less of a number of lines of code that you're actually writing. The syntax itself is similar to JavaScript. We picked JavaScript primarily because it's the most popular language in the entire world. 95% of all websites today use JavaScript. And so it's much more familiar, much more easier. It's not exactly JavaScript because it's our own programming language, but what it does is it allows you to learn or actually write your application in something that you're familiar with. The other thing too is that with blockchain development, one thing is that Ben said earlier today is that he didn't want to learn Solana development because it wasn't EVM compatible. This is actually a problem with multiple different chains. And if you learn one technology, it doesn't necessarily translate over. So Reach is a blockchain agnostic programming language, meaning that you can learn how to write in Reach and then deploy to any chain that you want just through a configuration change, which is really awesome. And the level of abstraction that you do write in is much higher level. Like I said earlier, is when you write in Solidity or any of the blockchain languages, you're writing at a very low level state machine, but with Reach, you're writing closer to the business logic. What you do is you write the application at the level of the participant. So, Alice does this, Bob does this. These are the transitions in between. And when you compile, it compiles out down to the smart contract, but also the client side of the code. So all you have to do is write the Reach application, and then you write the interface to communicate with it. Now, so Reach actually fixed the actual issue with the complexity, but the next thing that it fixes is how costly it is. So right now, if you actually go out and you take a look at the issue, try to hire a blockchain developer, some of them are making $300,000-$400,000 a year because of their experience doing it, and that's very expensive because there's so few of them out there. The other issue is that not only is it more expensive to hire those developers, it takes longer to develop blockchain applications, and so you end up spending a lot of money. On top of all of that, even if you actually write all of the, you get your application written, the amount of work that goes into auditing it to actually make sure that the code is correct, it costs tens of thousands of dollars. Actually, I was talking to a developer the other day that was building a decentralized exchange, and they got quoted $200,000 to actually audit their application. Just keep in mind, this is not coding it. This is after all the coding was done, and just have somebody else to go through and analyze and make sure they did it correctly, which is extremely expensive. But of course, if you don't do that, you could make it so all of your users lose all of their money. Now, how Reach fixes this is we implement a thing called formal verification. So you can think of what formal verification is similar to back when you're in geometry and you're given a formula, and rather than just plug in variables into the formula and see what the answer was, you wrote out by hand a long proof to prove that the formula is correct. Well, formal verification is the art of turning your entire application into a math problem and then generating a proof to prove that your application will work as you expect in every potential reality. Now, we do this automatically through a SMT solver. So we generate the proof through the compilation process. All you have to do is put into your code itself assertions on what the code is supposed to do, and then it outputs this proof, and then it won't even compile unless your code will do exactly as you expect. This is not testing. This is like testing on steroids, because with testing, the main thing that you can I always tell people, and this is a quote from Dijkstra, is that the only thing that testing can prove is the existence of bugs, not the absence. But formal verification can actually test your application in all potentialities to make sure that it does what you expect. Because of all of this, it makes auditing much faster process. Now, an auditor no longer needs to comb through all of the low-level functionality. They can look at the higher level of Reach code and say, "Oh, Chris, it looks like you didn't put in a certain assertion into your code itself. So I put that in there and I reran your compiler and it all passed. You're good to go." Or I reran your compiler and now it won't compile anymore because it doesn't pass this certain assertion that we put in there. And the cool thing about this is that every single time that you run your compiler application, that assertion is checked every time. So all the hard work the auditors put in can carry on from compile. The next thing that I like to talk about that is a problem with blockchain development that really kind of came up as I started getting into it is that if you get into like the Solana groups or the Solidity groups, you always hear people like either number one asking about, when number go up, how do I make more money, but not only that, but it's crypto itself incentivizes people to stick their flag into a certain protocol, because if for some reason they put all of their effort and learning into a certain protocol, they want their protocol to win. And you hear people talk trash over and over again to each other, and it's just not that fun in the actual blockchain community, especially in crypto Twitter. If you're out there at all, you hear a lot of people talk about, don't bother with Solana or EOS or what have you, because Ethereum is the only right thing. And that is, in my opinion, a big problem in the actual space, because it doesn't really make it so that you can, be, happy and not so toxic with each other. So Reach actually fixes this problem as well. And it didn't actually, when we started into building this product, we didn't think we were going to solve this problem because what we wanted to do is we build a blockchain agnostic platform that abstracted the actual blockchains around. And when we built it, we thought, oh, someone's going to come in and they're going to write their application in Reach and launch it on multiple different platforms. What we found is that people really don't launch their application on multiple different platforms. They already know where they want to launch it. But what we did find out is that by making it blockchain agnostic and abstracting the actual blockchains away, nobody at all asks, what chain are you developing on? They purely ask, I have this problem. Can you fix this? And because of that, it's really increased the network effects. And we have over 3,500 developers building blockchain applications. And very rarely do you see any type of mention of which chain they're building on. And that's really awesome as well. So like I said in the beginning, the whole idea of this is that I wanted this to be a very quick presentation and kind of open this up to Q&A, because I believe that's where we really get to the root of the problems that people are having, so I can answer them directly. But just a recap of what Reach is. So Reach is a programming language and a deployment tool that allows you to write in a high-level JavaScript-like syntax that allows you to quickly write your applications and launch it on multiple different blockchains. And through that process of compilation, it mathematically guarantees that it'll do exactly as you expect in all potentialities. Now, where Reach is, we started the actual company back in September of 2019. Since then, like I said, we've onboarded over 3,500 developers. This is not just only individual developers, but entire teams are building out applications, everything from decentralized stablecoins to decentralized exchanges to decentralized NFT marketplaces, smart NFTs, esports betting platforms. Pretty much everything that is being built on blockchain today, there is probably somebody out there building the same type of thing on Reach and having a much faster, easier experience doing so. So, of course, the final catchphrase is the future of blockchain is in Reach. I get paid $10 every time I say that. But mainly here, the best way to get started here is we have documentation at docs.reach.sh, and we have a very vibrant community in Discord that people are more than willing to answer any questions that come up. And if you just log in, you can see people chatting away. So if you don't want to jump in right away, you can kind of see how nice people are. But I believe that is all of my slides. I would like to stop sharing and really switch over to Q&A, if you guys don't mind.
Yeah, there's a question in the chat. Could we get a quick example of how the 1-to-10 ratio of Solidity is achieved?
Yeah. So what it is that in Solidity, the large majority of the code that you write are checks and balances. They're, require statements. There's making sure that the code is as bulletproof as possible. It's actually mostly boring things. If you look at a Solidity contract, as far as the business logic is concerned, a very small part of it is the logic of what goes into the application. So because of that, with Reach, we abstract a lot of that functionality away so that you can write primarily in the business logic, and it compiles down to, and it does output all of those extra boring lines, but it just makes it so you as a developer don't have to. This is actually very similar to how C compiles down to bytecode as well, because you don't necessarily need to write all of those things. The compiler takes care of it for you. And if you want to actually see real world examples, all of our code is open source, and we have entire folders of examples of everything that you'd want to see, and you can compile it and take a look at the actual Solidity, also the Algorand Teal, or anything that you would want to be able to see exactly how it outputs.
Thank you.
Mm-hmm. Giuseppe, are you a Solidity developer?
I'm web developer. I just started getting into Solidity just a few months ago.
Wonderful.
So I got really intrigued by how you basically solve this problem, and so I want to check out the documentation. And I just accessed the Discord channel. I mean, Reach sounds really interesting.
I appreciate it. Yeah, check it out. One thing I always tell everybody is actually do the tutorial. As web developers, we kind of skim things, read over like, oh, got it. Don't do that with a tutorial. I've done it. We've all done it. Just don't do it with this. If you go to docs.reach.sh, there's a tutorial section. It's a 9-part section that not only teaches you Reach, but it also teaches you how to build decentralized products. Because it's very important to understand that paradigm, and that you're not building a centralized application anymore. You have to build multiple pieces that all communicate with each other, and make sure that you build a proper ecosystem.
Thank you.
No problem.
Can I ask one more question?
You're the only one. Go for it.
All right, cool. So you were saying that, for example, Reach could work with any sort of JavaScript-based frameworks? So
no. So what it is that Reach is a JavaScript syntax, but it's not JavaScript. So what you do, so yes and no. So yes, you can, but you use the actual JavaScript frameworks as your interface, because Reach is not your interface. Reach is the actual blockchain portion of your application. You write the application, for example, rock, paper, scissors, Alice, Bob play, and all of the actual logic. But when it outputs the smart contract, but then it also outputs the client backend, which is a JavaScript file that you embed into whatever framework you want. And you communicate with that client through a callback. So, we've had people use Vue or React or just vanilla JavaScript, and you just build your interface however you want, and then you just call that one callback to interact with the blockchain. And you don't have to worry about all of the hard, boring stuff of keeping all of your transactions correct or anything. The backend takes care of that for you.
Cool. Thank you.
No problem.
Question I have, when I've been developing blockchain applications, I get, I guess maybe just talk about this, like an ABI file, which I've used for like my Python backend, then use that ABI to call the blockchain. Is there something similar to that in Reach, or like how is that handled?
That's the client backend. So when you output it, you get the contract, but you also get this, like what I call like bespoke SDK. That's you can actually, so JavaScript, you can interface with Reach with JavaScript, but we also have an RPC for Python, Go, and C# as well. So if you want to communicate with all of those, you just use that you can set up a RPC server to communicate with them as well.
Awesome, thank you.
No problem. Also, let's open up the floor to just general blockchain questions. I probably should have done this earlier, but give you guys my experience. So I've been in tech now for over 20 years. I've been in blockchain full time since early 2017. Before Reach, I ran a company building a scaling platform for blockchain. So I'm pretty deep into the space, and I've been doing it for a long time. And I know a lot about, or sorry, I would say I know a little about a lot of different things in blockchain. So open up to any type of questions, not even outside in Reach. Let's get weird with it.
David just put a question, and that's any examples of cross-blockchain smart contract, Ethereum/Solana, for example?
So cross-blockchain smart contract. So you really need to, I need to ask the question, like, what do you mean by that? Because like Reach, when you write your application in Reach, you can decide where you want to output it. Currently, you can output to any EVM projects. You can out to Algorand, and you can output to Conflux. The next one we do is Cosmos, and we're in the near future working on Starkware, which is the new layer 2 that uses ZK snarks. And there's actually a potential partner that makes it so that we can run on Cardano and Solana as well. So Reach by default is cross cross blockchain by writing your application in Reach. It automatically can launch on things. But if you're talking about interoperability, that's a whole completely different ball game. So is that which question specifically, so I can answer?
Yeah, I think you answered it. I know a little about Reach, but I understand it could be output to different for different blockchains. I was just thinking of an idea or a circumstance where a more complex contract could just consist of multiple kind of blockchains.
Yeah. So one
like
thing
a
that's
contract of contracts or something like that.
Yeah, that'd be difficult because of how contracts work and they run on the blockchain themselves. But what you could do is you could build a application, a client-side application that communicates with two different chains. And you could do that. And then depending on how you interface, you could, I don't know what you'd want to build, but you could do something like that where you could have a single application communicate with multiple chains.
Hi, I have a question.
Of course.
I'm David. Yeah, a couple of questions. First of all, what blockchains do you handle? And, do you translate to? And is the basics of this, is it you write it in some high level language, it's JavaScript-like language, and it translates into like Solidity or say Rust or Haskell or something for the particular blockchain? Is that what it's doing?
Yeah, but it does a little bit more than that. So it takes from the high level language, and when you compile it, compiles it down to the smart contract language, which we connect with EVM. So it outputs Solidity. It outputs code, it outputs TEA, and then it outputs the actual conflicts form of Solidity as well, which is not exactly EVM. And then with Cosmos, what it will do is it'll output the entire JavaScript or the entire blockchain node, because what Cosmos is their application specific blockchains. So it outputs the entire, I forget what they call them in Cosmos, but so then you can then pass that from to all of your verifiers to verify your application specific blockchain. But the idea is you write in the high level code and it outputs down to the exact language that you need to run in the blockchain you want.
Okay, thanks.
No problem.
I guess my question would be on deployment. So in apps I've built before, I use Truffle and I have Impura and I push my code to the blockchain. I guess as Reach you mentioned has a deployment mechanism. Can you maybe talk about that?
Yeah, so we have deployment tools built into the actual Reach itself. So we automatically stand up the node you want to test or run your application on, so your own DevNet. But to run to like launch on testnet or launch a production, it's literally just pointing to a different endpoint, because what we stand up locally is the official network. It's a network of one. So yeah, so like you no longer need Truffle or anything of that sort, because it's a completely different system. We are in the process right now of building a very complex debugging tool that we actually brought on a specialist that knows how to actually visualize like formal specs, so that you'll be able to simulate the entire application and step through directly in the IDE itself. So that is in the process of being built. But that's not built yet. But at the same time, you'll always have your log files and things of that sort to understand what's happening. You can actually launch it on a ganache if you wanted to actually have specific control over the nodes itself. That is an option that some people use. But to run the application is as simple as doing a reach run. And it automatically stands up everything and then runs all your automated tests. The cool thing is like setting up automated tests is as simple as writing more JavaScript that just automatically calls certain endpoints, and they can run through things for you. Once you go through the tutorial, the first like 5 steps of the tutorial is you write a automated test that steps through a game of rock, paper, scissors, and then it allows you to turn it into an interface, a command line interface, and then it shows you how to connect to a browser, a web interface. So who here has an idea for a blockchain application? That's one to kind of talk about it. Anybody?
One thing I've been kind of noodling around. I'm kind of new to smart contracts and blockchain in general, but one thing I've been noodling around was a web interface for a smart contract where you can press a button and you get paid, if you're a freelancer or something like that, based on approval. Basically like a pull request for a client. They said, yes, you're approved, and you press the button, and it's really a smart contract, and you get whatever agreed upon fee.
So have you heard of Gitcoin? Gitcoin?
Yes, I have.
They have that functionality where for open source software where you put out proposals or bounties, and people can actually submit them, and they automatically get paid through the smart contracts. I think it's actually a pretty cool idea. One of the things, though, that there's another project out there called Riot DAO. Steph, is that what they're called? The software services company that's a DAO.
Repeat it one more time.
Is it what's the software development DAO?
Guild.
Raid Guild. So there's a DAO out there called Raid Guild that it works in a similar way, where it's a set of service providers that are part of the DAO, or decentralized autonomous organization, that works in a similar type of way as well. So I think it's a good idea.
Okay. How do you spell that? Radio? Raid,
like RAID, Guild, GUILD. Guild.
Okay. Thanks.
No problem. What else you guys got?
Christopher, this is Don Lothan. One of the challenges I've seen people run into is just the basic record keeping, the storage of documents. I know
Sure.
a lot of people are using IPFS, the interplanetary file system. It doesn't really lend itself to mistakes and corrections and, oopsies. So what have you seen around kind of a process flow where you would have a document storage, perhaps abstracted with the hash going onto a chain, and some of the more detailed information being held off chain?
Yeah. So I haven't seen anybody do something good, but I did a podcast. I think episode 3. I think episode 3 was. So I do a podcast called Better on Blockchain, where we go from industry to industry. And the 3rd episode, we decided to tackle like office suites, and how could blockchain make the office suite better. And we go into like an hour-long diatribe about how you could use blockchain for everything from immutable tracking of changes to copyright and pretty much creating NFTs from the actual documentation process to actually signing, all with blockchain. But you wouldn't store the files on the blockchain, because that would be very inefficient. You would use some type of decentralized storage and updating the hashes as you go, and updating the blockchain with the actual change, the new hash, and who made the changes as well. So that's kind of probably what I would recommend doing. And I don't think anybody's actually done this yet, but I recommend you check out my podcast about it. I can see if I can find a link.
I mean, what you're describing, makes sense, but I've seen some kind of pilots or prototypes where they lay in some type of traditional database layer as a pointer, and then that would be kind of your first place to look. Has this particular hash entry been updated, or can I go, where's my pointer going, to First
Right.
version, second version, third version.
Yeah. So what I would recommend doing, like I once again, I have not seen anybody done it. How I would tell you to build it would be to, how I would do is I would actually create an NFT for a specific document, and how I would actually to do it is I would
So
create
you
a
using that as an access token.
yeah, but not an access token, but more of a marker of ownership of a pointer to a document. But what I would do is I would create a mutable field inside of this NFT that would allow the owner of the NFT to be able to update the hash of the actual current state of that document. That way that you could actually designate ownership and then track the changes over time with that same NFT, because every single change would be the state change would be tracked on the blockchain. So you'd be able to actually see the eventual changes over time. The downside, of course, is that you would have to store most likely a change log, a hash of a change log each time, with a base, very similar to like how Git works and things of that sort. But you could do that. And then what you could do is then that NFT could then designate ownership of the final change. And then that could be like the immutable log of all of the changes. And because the other thing too is you could, because another podcast that I do is on NFTs, which I think is episode 4. We talk about what an NFT really is and what an NFT can be, because an NFT is really just self-sovereign ownership, and there's no reason that a NFT can't be owned by multiple people, because it's just a data structure that points at a certain thing. You could have multiple owners of a single NFT. That those owners would have the ability to modify the change logs of that NFT if you wanted to.
So you mentioned self-sovereign. Would you kind of factor in some of the DID work that's taking place in terms of the kind of pointers to the NFT ownership?
You could. I think that's all of that is kind of really still a little new. The good news is that an NFT like this, you probably know who the other people are, just because, of just the meat space. But if you needed some type of extra DID identity, then yeah, you could go that way. But really the idea is that the way that I would do it is I would create this NFT and I would be the primary owner. But then I can actually add access to modifying the change logs by sending, say, you, John, in the actual regular space, hey, here's the key to the access to this. Connect up to your wallet with this key, and boom, now you have the access. So now there's 2 owners on it. And you could just do that to everybody that you would want to be able to modify the single document and be able to continuously modify that change hash as you go.
You mentioned wallets. Any thoughts on kind of the merger of identity wallets with crypto wallets?
I think that's a great question. And so Reach is working on what we call the Reach ID, which is a combination of identity with wallet. I personally believe DID is more of a attribute of an identity rather than an identity. This is actually a whole thing I go really deep on, is that what is identity? And I believe that too many people are taking the real world meat space, like definition of identity, and forcing it onto the blockchain, because in the blockchain, it provides extra features that the real world doesn't have. So the main thing that I always say is that what is identity? It's a collection of your experiences and reactions to the experiences. On the blockchain, that's all trackable and that's all transparent. But at the same time, it's very possible that you have different identities on the blockchain, and that's okay. That an identity can be made up of several identities. And what you could do then is, by having several identities all under a central identities, you'd be able to apply multiple identities to a certain application if you needed to increase the weight of your identity. But this is actually, once again, I could get really deep into this, but
it's an interesting discussion. I mean, I would look at it. You have one and only one identity, and then you have a series of kind of claims buckets, if you will. And those claim buckets carry some attributes for specific types of transactions and specific claims that you might be interested in either proving or collecting.
Yeah, I mean, I think it's semantic, really, but it's really it mattered. Like at the same time, I do believe people have different identities. I mean, if you go on Fortran, I bet you those people aren't nearly as nasty in the regular life, and they want to keep them separate. And I just think that, like, I mean, that's an extreme case, but I do believe that human beings act differently depending on the situation that they're in, which changes their entire identity. And at the same time, they don't want to blend those identities either. But there are times that you would need to be able to blend identities in a non-transparent way to give yourself extra collateral to do things on the blockchain. So, like I said, it's an abstract way of thinking about things for sure.
Yeah, I think semantics is a good term for that.
Yeah.
I guess a question for Learning Reach, is it more geared for somebody that's had some programming experience, or how would someone that's relatively new kind of onboard into the Reach ecosystem?
Yeah, so what I'd say is that for the most part, you should have some type of development experience, like building web applications or mobile applications or something. We have had people completely cut their teeth on Reach, but it's more difficult for them because they're learning development and then they're learning decentralized development on top of it. So I think our first or second hackathon that we ever had was won by an 11-year-old. So like it is for everybody. He built a fully 3D tic-tac-toe game that was fully decentralized, so all logic on the blockchain.
Awesome. Yes.
What is the kid doing now?
I don't know. I've never, I mean, the beauty of the blockchain, who knows? Who knows?
Any thoughts about IoT devices and kind of some of the edge computing that may carry its own blockchain?
Yeah, I think that there is like special cases. I think you could use the blockchain for like immutable logs. I think that's one of the things. And there is something like as far as like proven computation and things like that, but it's outside of my wheelhouse.
Is it okay if we go a little bit more sort of like broad, abstract, and how you see, for example, the regular person interacting with the blockchain in the near future, next few months to a year or something like that?
Yeah. So I believe that the thing that will bring the mainstream into blockchain is what I call smart NFTs, NFTs that have functionality. Once again, going back to what NFTs really are is self-sovereign ownership. They're not trading JPEGs. That's not really what NFTs are. That's what it feels they are, but that's not what they really are. But when you actually start thinking about it, that an NFT really is just a data structure. That one of the actual fields on the data structure is ownership, and the functionality of that NFT is the ability to change the ownership, change that one field. It really opens your mind what NFTs can be, because if NFTs can do that, you can start putting rules around ownership. You can put rules around transfer, and you can actually add extra fields to that data structure. And it is still all self-sovereign, meaning that it is all baked into that one asset. So there's no need for overhead to monitor all of this. You're going to see things like, royalties being built into the NFT, so that when I sell you the NFT, a small percentage goes back to the original creator. You're going to see things like evolving NFTs. If you interact with an NFT in a certain way, it turns into a different thing. And because of that different thing, it allows for more functionality. You're going to see, like, one of the examples that I love to use is that, say you're a venue and you want to sell a VIP pass, like a lifetime VIP pass to all concerts forever, right? As you can probably understand, you probably don't want that pass to get into the wrong hands. So what you could do is say, okay, we're going to create a set of non-transferable NFTs that we'll call it the casino club, right? And to get a casino club NFT, there's thousands of them, or we can print as many as we want of these. You have to apply for it. We're going to look at you and we're going to give you this NFT. And now you're part of the club. You can get some other aspects of it. But then you program into the VIP lifetime concert NFT that you can only transfer to people that have that club NFT. And what this will allow for is that it would allow for the casino to pre-register, whitelist all of the people that could potentially receive that, but still allow for that VIP pass to be self-sovereign. And they could tie in royalties to it. So not only can they say who can trade it, they can say that every single time that it's trades, we get a percentage of it. You could go in as far as say, okay, every time that it trades, I don't want I want royalties, but if it does change hands, me as the creator, I want first dibs to pay for it what the other person is paying for it, because if they're trying to actually sell it for $1 to get around royalties, I want to buy it back because I know it's worth less than that. You can build all of this into the NFT itself, into a smart NFT, and not have any extra overhead because it would be bundled with the asset itself. And I believe that is what's going to be the near-term thing that's just going to push blockchain into the hands of the masses.
Sounds like an excellent case for estate planning in a closely held family organization.
Yeah.
You want to hold on to the shares. Certain family members could bid on them, but they're not leaving the family control.
Right. Yeah, you can do all of these things. You can do it completely on the blockchain. So I would say that's probably in the near term. You're going to see a lot more in the digital media space around smart NFTs as well, because you'll see people buying and selling NFTs that give rights to listen to music. So what you'll see is that, the return of collecting albums, but there will be a return of collecting the NFT albums, that if you own the NFT, you have the ability to actually listen to that. The NFT also has digital a image representation. So you could actually have a wall of albums if you wanted to, or you could flip through it. And if you have the NFT, then you can be able to listen to that music. If you don't want to listen to that music anymore, you could actually sell it, have royalties baked into the NFT so that the original artists have the ability to could generate money forever based off that. You'll see a lot of that as well, probably in the near future.
So talking about this like music example, earlier you were saying that as a data structure, NFT can actually point to different owners at the same time. You
could, sure. I mean, really is you need to stop thinking of NFTs as like an asset and more of just like a data structure. And you could make it do it. One thing that you could do is that you could designate a fungible token as the owner of an NFT. And you could then say that anybody then has a portion of the ownership could actually have a portion of the future royalties of this NFT based off of the actual holder of the fungible token, which the fungible token is actually the ownership of the NFT itself.
Nice. Thank you.
No problem.
Hey, Chris.
Hey, JP.
Hey, so much of blockchain is getting a new mindset and thinking about like the world differently. And I was driving, so if you already answered this, forgive me and pass on. But could you talk about kind of like the mindset of developing in Reach and building the applications in Reach?
Yeah. So really the mindset of, so traditionally when you're building a blockchain application, what you're doing is you have to actually think of all of the different states of your application and how everything would actually interact with that state and how you would make sure that the states don't get stuck. And so like I said earlier, is like you're building a state machine. But that's hard to do it right, which is why most people just go to Open Zeppelin, grab a template and say, fine, this is actually what it is. That does not allow for innovation. What that means, that's the only people that can innovate in the entire world are the template creators. But what Reach allows you to do is it allows you to actually write the application at the level of the participant. So, Alice plays let's talk about rock, paper, scissors, for example. So Alice says, I want to play rock, paper, scissors, and I want to bet 10 Algorand or 10 Algo. So they put a contract in the world and say, here, I'm going to play rock, paper, scissors, and I'm going to bet 10 Algo. And who wants to play with me? And then Bob comes along and say, hey, I'll play rock, paper, scissors with you, and I'll bet you 10 Algo. So then Bob says, okay, here's 10 Algo in the contract. So now there's 20 Algo sitting in the contract. And Alice says, great, let's play. Alice then says, okay, I'm going to play rock, but I can't just play rock because if I put rock on the actual blockchain, Bob would just look at the blockchain and say, oh, Alice played rock, so I'm going to play paper. I'm going to guarantee win. So what Alice does is say, okay, I'm going to play rock, but I'm going to conceal my hands and store the hash plus some salt of what my hand is on the blockchain. So Bob would have no idea what the thing is I hand, but all Bob can see is that Alice played. So Bob looks like, oh, great, Alice plays. I'm going to play scissors because Alice already played. She can actually see what my thing is on the blockchain. So I play scissors. So Bob plays scissors, and then Alice goes, okay, here is actually the hand I played, and here's the actual matching the encryption to go with it to show like, yep, I actually played whatever Alice played. And then the blockchain goes, okay, well, if Bob played scissors and Alice played rock, then Alice wins, and I'm going to transfer all of the money to Alice. And that's kind of what you do. That's how you program in Reach. But then the question is like, okay, well, that's pretty straightforward. But now you want to program timeouts. What happens if Alice plays and Bob never plays a hand? After a certain amount of time, you're going to want to return the money back to Alice because Bob didn't play. What happens if Alice plays the encrypted one, Bob plays, and Alice looks and goes, oh, I lost. I'm not going to actually do anything. You need to make it so that if Alice says, okay, step back and I'm not going to show it, then Bob wins all the money. So she's incentivized to continue to play the game. Good news is that Reach makes this all easy because it puts your branching logic tree into the actual code itself. And rock, paper, scissors is literally, I think, 85 lines of code in Reach. If you wrote that out by hand in Solidity, you're talking about a tremendous amount of code, and you're probably going to get it wrong and lose everybody's money.
How good is Reach, like in your example, let's say, how good is Reach in creating the code? You were talking about auditing and all sorts of things, but how good is it in reality? Because I know people work a lot in Solidity. I'm not familiar with Solidity directly myself,
Sure.
but people spend a lot of time on it, and they obviously make mistakes because there's, we've heard about some very famous ones, and I'm sure there's a lot of less famous errors and problems that occur. How accurate is the translation?
That is the whole thing with Reach, is that we actually formally verify that the translation is correct, meaning that we mathematically prove that your code will do exactly as you expect. So the truth is that a human will always be able to optimize more than a compiler. So if you're building something that needs to be highly optimized, it's always going to be better to actually do it by hand. but nobody on this call has the ability to actually optimize it better than compiler. And this is the same thing. That's why Google hires PhDs every year to write parts of their code in assembly, because there's certain things that need to be, tons of time and money and effort to put into to actually optimize small portions to make that right. And there will always be things like that in the blockchain where certain functions need to be perfect. And we need to actually optimize it down to a T, and it will be better to actually do it by hand. That's just 0.001% of the time that's actually valuable.
Are you trying to make the case so did you write, were you the one who originally wrote Reach, or I know you're the CEO?
My co-founder did.
Oh, okay. But you're trying to make the case that if somebody's starting to do smart contracts, and I've played around with it a little bit, but that you're better off using Reach than, say, one of the native languages like Solidity.
I would go as far as to say I'm not trying to make the case that the case has already been proven. We've got to a point where we can get a developer up and running to a point of building an entire decentralized exchange from scratch in about a month's time. If you think that you can do that in Solidity with never building anything before, like that's just not even close to possible.
Mm-hmm. Well, that's great.
Yeah, I mean, we're really bullish. I mean, as far as actually the state of what Reach is, like we're very legit. Algorand has come out and said that Reach is the best way to build applications on Algorand's. Conflux is we're getting to that point with them. Ethereum is like the problem with Ethereum is that it's full of people that I like to say are pot committed. They spent the last 3 years doing it the hard way. So trying to convince them to come over that are already is tough, but the new developers coming in, we're going to be making a big push in Q1 next year around smart NFTs, because like I said, I think it's going to be a big push. And to give you an idea, one of my VPs of engineering was handed a proposal by one of his friends and said, "Hey, I'm trying to build a smart NFT that's like evolves and has royalties." And I asked around and I got a quote, and it's going to take about 6 to 9 months to build this. The same application could be built in 2 weeks with Reach. So we're going to make a big push in Q1 around the marketing of this to show, hey, it's not even close.
Wow. Do you handle, what about Solana and, what about Solana? Does Reach handle Solana today?
We don't do Solana yet. We will do everything eventually. Our roadmap is dictated from our partnerships because the chains themselves, they keep our lights on.
Okay.
Because it's a completely free language that anybody can use, and we want to keep it that way. So the protocols are the ones to foot the bill.
Mm-hmm.
All right, we are at time, but this has been a great convo, and there was a lot of questions. So, is there a way to reach you, Chris?
Come to my Discord. I'm always there. My DMs are open, and I'll be happy to answer anything. But like I said, don't stick it to just Reach, because like blockchain development in general is the thing that we need to solve. Not just when we try to teach things, we don't teach you how to do things in Reach. We teach you how to build things for blockchain, and the vehicle to do it is in Reach. So come on over.
So let's join the Discord.
I just posted the link to the Discord in the chat if you guys want to join us.
Oh, thanks a lot.
Awesome.